Just before I kick off, this is going to be quite a developer-focused session that I'm going to present. So, if you're not following along with me, don't worry. Can I have a slight show of hands who in here actually develops software for a living? Oh, well, in that case, I'm absolutely not worried about this at all. Who am I? I'm the UK New Group Manager for the Link.net Users Group. Yes, I'm a Microsoftie. Please don't hold that against me. I've been doing IT and computing since the early 1980s, and I now run a local consultancy service offering IT services to local businesses, startups, and basically anybody who wants to sit and listen to me. If you want to contact me, you can find me on Twitter. I've got a blog when I find time to update it, and you can find me on Skype with the same handle as my Twitter handle. So what are we going to talk about tonight? Well, we're going to define what developer privacy and security is all about. I'm going to highlight some of the bad things that have already happened in the industry and show you some of the abuse of some of the various technologies that's already taken place, and a couple of signs that you might need to watch out for to know whether you're leaking data in any applications or websites that you might be developing. I apologise in advance for the lack of pretty pictures. This is all white slides with black text, so it's going to be fairly boring. First, a disclaimer. I'm not a lawyer. I'm not legally bound to any course of law in the UK. I will mention some things that I've learned over the years, but please understand that any information I do provide cannot be legally binding, and it may not be 100% accurate. If anything that I discuss with you has any legal ramifications that you want to learn about, consult a professional. Okay, so defining developer privacy and security. What crosses your mind when you see developer, security and privacy all used together? Do you start thinking about the security of your development team and keeping them safe in the workplace? Do you start thinking about your developers making sure that your company's data is being kept safe and secure? Do you start to think about being certain that your developers are doing all they can to make sure that your app or your website or whatever it is you're developing treats the personal data provided by your users securely and only for the purpose that it should be used for? If you chose only one of those statements I mentioned on the last slide, then I'm sorry, but you chose incorrectly. Security and privacy in any application or IT project is not just about preventing data from leaking or making sure that your input is sanitized against things like SQL injection attacks. And the media doesn't help here either, because they love to grab the scare stories that are guaranteed to grab people's attention. The reality of the matter is that security is about everything, and I mean everything. If you leak data, that's bad. But if your developers are letting data out either intentionally or unintentionally, that's just as bad. The reality is there's more data breaches occur either during the development phase or through employees being reckless or even setting out to intentionally damage the reputation of the company than there are breaches caused through a malicious hack or a social engineering attempt. Example number 1. Do you know exactly what your developers are using for testing while they're building your products? Anybody come across anything like that before? Any bad stories? Well, I've seen more developers than I would like to want to see use their own personal details, their own debit card numbers, their own email addresses, their own Twitter handles when they're testing applications. And a lot of people don't realise that if that developer then leaves the company and the application was later breached, that developer can pursue that company for damages, for a lawsuit for unintentional release of data that he or she put into that database in the first place. The company from whom the leak occurred is still legally responsible, no matter where that data was sourced at. If it's leaked, the company that leaked it is held accountable by the UK's Information Commission Ministry. Number 2, where you're sourcing your test data for your development. Many teams use generic names like Joe Blogs, Jane Doe. We've all seen them in the test databases. But they're still legal names. There are people out there in the world that have these names that they're legally entitled to call themselves by. And if they really, really wanted to, and damage was caused because that name was used and then that data was later breached, they can take a civil case against that company and have them prosecuted for leaking that data. What data does your staff have access to? I mean, exactly what data does your staff have access to? Many organisations grant access to all of the company's systems without ever actually thinking what they do or don't need to do their job properly. Let's take an example. Jeff, the sweet treats sales guy, sells sweets for a living. Does he really need access to the customer's full postal address, the date of birth, the hobbies, the number of times they logged onto the website, the kind of mobile device they were using, and the last time they went for a haircut? Nah. Jeff just needs to know what their favourite flavour of sweets were, and when they last went to buy some, and how many they bought, so he can maybe tempt them with some new flavour or something. Why would he need that extra data? The answer is he wouldn't. But the reason he has access to it is because the company hasn't put proper data protection practices into effect. There is no developer or staff security guidelines. Internal staff have not been able to sign a yearly staff contract, a yearly security contract. I worked for Orange Mobile for 4.5 years. Every 6 months we had to sign a security agreement. If we did not sign that, our jobs were put at risk. And that security agreement was our signature to say that we will not abuse the access that we've been given to the systems that we've been given access to. And just for the record here, I could read the SMS of everybody on the Orange network if I wanted to. I could tell what MMS and what emails were sent from what handset to another handset at any time of day or night. Why, if companies like Orange, and for a large part the financial institutions now with PCI DSS, can get this right, can many other businesses not get this right? Of course, there is one other thing as well with Jeff the Sweetie salesman. How do you know who he's talking to when he leaves work? He might be going down the pub and selling data, or he might even be on eBay as Mr. Sweetie Data Man 42, selling all your data to rival companies. You never know. So, it works both ways. Privacy and security secures your developers, your staff, and anybody within your organisation. It stops you from getting into trouble. It stops you from getting into trouble, and it makes sure that only what needs to flow across the wire, where it needs to be, when it needs to be. Just for record, this statement about protecting your staff's internal security as well extends to putting a team list up on the company's website. How many startups do you see that love putting up the team list of all these co-founders and people who've built this great new thing that they're developing? They all do. photograph, little bio, little animated flip card, things like that. If that member of staff doesn't want that data putting up there, or that member of staff does not want to associate their social networks with a company or a startup that they might be working with, you have no legal right to force them to do that. You have no legal right to put that up on the website, because again, they can prosecute you. Once that data goes out of their control and they cannot exert any influence that data might be given from external forces, you are held accountable for anything that data can get used for. So let's look at some of the bad things that have already happened. Unintentional data leakage. A large shopping centre in Australia, I'm not going to mention any names here, caused a storm when it was found that they were leaking data that potentially could have been used by a third party to track a person's whereabouts. The shopping centre, like many large enterprises, wanted an iPhone application that helped their shoppers in many different ways, helped them locate shops, helped them find where they parked the car, and a myriad of other things. Unfortunately, the security of the application was poorly thought out. Probably not even considered until it was too late and the breach had been uncovered. The application in question, like many modern mobile apps these days, was powered by a back-end JSON API. The API was left wide open. There was no security, there was no developer keys, nothing. And it was possible to use the JSON API just simply by monitoring the application's flow using a man-in-the-middle program such as Fiddler. And it was possible to get a list of all 2,000 parking spaces in the shopping centre and the cars parked in them, but more scarily, in amongst all that data, in plain English, was every car's registration number. This happened because the designers, when they designed the application, designed it so that you could put your registration plate in and it would return 4 photographs. Those photographs were taken by roof-mounted cameras in between each of the parking bays. When a car pulled in, a photograph was taken of the back of the car and OCR was performed on the reg plate. The reg plate, being OCR, may not be entirely accurate, but it had something like a 98% score. So the developers felt that it was fine to return 4 images to the person's phone and say, touch which one's yours. Most people recognise what their car looks like, job done. Again, the registration plates of all 4 vehicles was in the JSON data that was passed across. And the final part of the puzzle is, all of this was done across the shopping centre's free public Wi-Fi connection. Browser history hack. Until recently, any JavaScript running inside a browser had full unfettered access to the JavaScript history object. Now, that might not seem like a big deal. It's interesting to know what's in the browser's history, particularly if you're writing single-page apps. You might want to be able to go backwards and forwards through the different tabs and different pages. It was found pretty quickly, however, that this had been exploited in a way that the W3C committee and the Security Standards Committee that make the rules for all of this thing hadn't anticipated. The loophole's now largely being closed, but there are some older browsers out there that still have this problem. How did it work? Well, it was quite simple. Anybody who works with any kind of browser knows that browsers have a default style sheet. If you go and visit a link and then you come back and you put that link into a page, that link will show in sort of a purple colour, whereas an unvisited link might show in a blue colour. That's all well and good when you're looking at it, but what was found was that the browser history could be extracted. It could be put into an off-screen div, something like that, hidden outside of the user's view, and then the CSS rules of the links could be queried. And any links that had been visited exhibited CSS style rules that gave it the purple colour. Thus, people exploiting this were able to tell what links you visited. Not long after that, it was found that an extension to this had also been put into wide circulation, where large analytics companies were actually taking whole lists of URLs that they were interested in, putting them in a div, rendering them off screen, and then comparing them and running them through the JavaScript history object to see which ones changed colour, so that they could tell if you had been to a competitor's website, or if you'd looked at something that they were interested in linking your data to another aspect of. Staff posting details on social networks. This is actually a very difficult point to deal with for most companies. Small, large, doesn't matter your size. Because on one hand, you need to connect with your customers and your user base. We write these apps, we write these websites because we want people to come and use them. And we need to support those people. On the other hand, we need to make sure that we're not putting ourselves at risk. I mean, so far you've seen more than a few ways that you could potentially shoot yourself in the foot very, very easily. Staff who post blogs, help forums, Facebook updates, things like that must have their content validated before they even go anywhere near publishing it. And while I'm on that subject, Twitter direct messages. Twitter DMs are not a support channel. I see all the time one of the most prolific companies on the planet, and they're absolutely tremendous for abusing this, are Lloyds Bank. If you watch the Lloyds Bank Twitter stream, every other Twitter message practically is one of their help support personnel saying, "We're sorry to hear about the problem you've had, please DM us your account number and we'll get it looked into." And then people just blindly go and follow that advice thinking, well, these support people know what they're doing, so I'll go and help them. And then you find that this person sat in Starbucks talking to them while he's having a cup of coffee. And there's somebody sat outside in the car park with a Linux laptop running Backtrack and sitting there with a copy of Firesheep or something on. And, well, I'm sorry, but it's game over then. You're stuffed. Your account number's in the public domain. It might just be your account number in that instance, but what about a shop that might perhaps say, sorry, your purchase didn't go through. If you give us your bank card number and sort account number, we'll run it through again and see if it works. No. Stop it. DMs are not a support channel. They're there to help, but they are not a support channel for private details because they are not secure. One thing people forget about public Wi-Fi spots with relation to this is many Wi-Fi spots, from a technical point of view, are not a switched connection. A switched connection pushes all the data available on all the interfaces to every point on that device. If it's switched, it sends it only to the channel for which it's destined. This is why public Wi-Fi is a really bad idea when you're doing anything like this. So, logged in pages. How many of you when you go to log in somewhere, look at the browser, login page comes up, and you look for the little padlock and your HTTPS, and you feel all warm and cosy because you know that that company's took all the steps it can to make sure that you send your password and your username over a secure channel. Yeah? Great, isn't it? Nice to know that they're looking after you. But then what do? They go and switch back to HTTP. Right, okay, so you've put a login in, you've gone back to a HTTP page. Because you're using a HTTP page, you can't use HTTPS secure session cookies. And if you can't use HTTPS session cookies, that means that your session information is available to be sniffed off the wire. Just like your direct message from Twitter, or your email login, or anything else. I mean, if you want to give away access to your account, that's fine. But no, this is another bad thing, and it's a bad practice that many, many companies do time and time and time again, and it's something else that needs to stop. It only takes one slip up. It only takes for somebody to take one of Doug's advertisers that puts something nefarious into an iframe to trip the entire system up, and you might well have never even bothered trying to protect your ass. Because the second that un-HTTPS content comes in an iframe alongside anything that you haven't chosen to secure, the whole lot just gets blown open wide. Passwords themselves. How many of you store passwords in a hashed format in your databases? Yeah. Do you salt them at all? Anybody? One person. Yeah. Two person. Yeah? Please add a salt to your passwords. Rainbow tables these days are not just a joke that they were 5 years ago. Your average NVIDIA FX440 graphics card has a GPU on it with 160 parallel processing units. That thing can crack MD5 hashes using the CUDA development kit at the rate of about 1,000 attempts a second. You take one of the higher end cards, like the really modern up-to-date cards that have 300, 400, 500 parallel processing units in, and that figure suddenly starts to get incredibly scary. Add into the mix programs like John the Ripper. John the Ripper's been around pretty much since the beginning of the Unix and the Linux revolution. And it's a very, very effective piece of software. I've personally ran it over shadow passwords files on people's Unix systems before, and ridiculously easy to get the passwords out of it. But you take the modern versions that can now use things like CUDA and the parallel processing available on a lot of these graphics cards, and you've just got no protection anymore. Couple that with the fact that there's so many rainbow tables out there. How many of you have used a web service to decode and encode MD5 and base 64 strings? Yeah? Well, do you know what they're doing with your data behind the scenes when you put it in? I don't, but I'm willing to guess that there's more than a handful of them there that are going, he's typed that in, that looks like a password, that's the MD5 hash for it. Ship it off to some rainbow table processing website where it'll get added to a global database for people to check against. Salt them. Or, if you can't salt them, use something that's going to slow the attack down, like Blowfish, or something like that to encrypt the passwords. Okay, so what abuses have we seen so far of the various technologies? Cookies. Everybody knows the humble little cookie. Unlike what the media will have you believe, cookies cannot spread viruses, store your life history, or anything like that. So why have we now got ourselves into a situation where the European Economic Community think that it's justified to make every single one of us put a little question on our site with a button that says, "Hey Joe, am I alright to store cookies on your browser?" Well, it's because large e-commerce industries, being the idiots that they are, have decided that it's perfectly okay to abuse a harmless little technology like this. And like I said previously, the media absolutely love to scare people. They love the stories that have resulted in 11 billion passwords getting released on the paste bin. And then, of course, everything gets blown out of proportion, and politicians being who they are, they sit there, the knee-jerk reaction goes up into the air, and all of a sudden, everybody else has to suffer for it. Cookies, however, are next to nothing compared to this next one. Fingerprinting. Anybody know what fingerprinting is? Fingerprinting is destined to get worse. The more we add to our browsers, the more toolbars, the more user agent headers, the more things we try to run, the more APIs we reveal, the more identifiable information that we use to try and make people's experiences richer, the more accurate fingerprinting is going to get. At this present moment in time, the average score from a fingerprinted website in terms of personally identifying a person is roughly round about 78%. I've seen some code that's not quite yet made it into the public domain that gets that up to about 98%. And it's going to get worse. However, there's one badass that's even more dangerous than normal fingerprinting. Canvas fingerprinting. Anybody heard of that one yet? One of the areas in HTML5 that the W3C have considered is not dangerous enough to surround with all the usual security barriers is that of image transfer. Now, couple that with the new file system API that's available, where you can build a blob storage in the actual web page without touching the user's hard drive, and then ship that blob as an image back across the wire, uploaded to your server just like somebody had hit a file upload button, all without the user knowing, is quite a scary prospect. Now couple that with the previous fingerprinting idea, taking data from the browser and drawing a lovely little pretty picture, off screen, on screen, doesn't really matter. Some sort of barcode maybe, 2D barcode, 3D barcode, who cares, doesn't matter. What you draw is absolutely 100% personally identifying. And that can be drawn in the browser based on current environment on that user's machine and then sent back across the wire without you ever even knowing that that's happened. Canvas fingerprinting is an incredibly dangerous technique, so much so that the European Economic Community currently have bills going through their parliamentary processes to exert control on this. There are various white papers out there, unfortunately I don't have the links with me at the moment, but a quick Google search will turf them up in the sort of first page of results and what have you. But they've considered that this is such a dangerous technique, they're looking to control it before it even gets widespread use. And then, of course, there's the continuous exploitation of HTML security measures. It's not just the hackers and the crackers you've got to watch out for. It's not just the bad developers that you've got to watch out for. You know? As Doug said, there's companies out there that want your data, and they're going to do everything that they can to break anything that us busy developers try to put into our applications to prevent them from doing that. Yeah? Doesn't matter how much we try to secure our data. It doesn't matter how rock solid we make our JSON APIs. It doesn't matter how careful we are sanitizing our inputs and our outputs. These guys want to find ways around it because they want to be able to exploit what it is that we're developing in order to get that data out of the end user. So finally, we'll move on to a few little signs that you might be leaking data. Well, your JSON APIs, are you authenticating them? If you're not, you should be. And I mean really should be. I'm not talking about API keys and developer keys. If you're working in PHP with Laravel, for example, don't just apply your security mechanism to any pages that the end user might log into or might be viewing. Yeah? Run your API off the same controllers that you're using for displaying your pages and put the same authentication code in those controllers. And then find a way to allow that authentication not only to be provided from a login page on a regular website page, but also from a JSON postcode. Do you know who's using them? If you're not monitoring your APIs, you should be. You know, weblogs are not good enough. If you're working on a high capacity site that gets 10,000 hits a minute, or 20,000 a second, or whatever the hell it gets, your weblog's going to be updating far too fast for you to say, oh, there's company 1, there's company 2, there's company 3. Even the most demanding Node.js application is not going to be able to parse and filter that thing fast enough. So put extra logging in. Every time there's an API call, stick it in a document database like Mongo. Stick it in Postgres. I don't care what you do with it, just log it. Don't let anybody use that system without you knowing where it's come from and who made that call. Public APIs that make no attempt to filter data. How many of you have got CRUD APIs on your back end? How many of those CRUD APIs, I can see a smile there, how many of those CRUD APIs mirror the database schema? Well, you'd be surprised how many there are out there. Try having a look for them. There's a load of them. Get record, /person/info/1. And that entire row from the database comes through in JSON, including the password hash. You know? Filter your data. Don't return the record as it is. An API only needs to put the data that it needs for whatever the task the front end needs to perform across the white end. Don't put across any more data than you need. Are you depending on too many third parties? Twitter and Facebook are great for single logins, yeah? OAuth and all that stuff. But do you really need the Facebook friends count and the number of messages they posted and the number of cute cat photos that they uploaded that day? If all you're doing is using it for authentication, then all you need is their name and a unique token. So just consume that. Don't ask for everything that the Facebook or the Twitter or the Google Plus API gives you just because you can. If you don't need it, don't request it. The less you request, the less there is to be leaked in public. It's as simple as that. So, there's more to privacy and data security than most people think. Give people access only to what they need, strictly control any data used for testing purposes. It extends to everybody. It's not a one-stop thing. Security is an ongoing process. It must be thought about and planned right from the beginning. It's not something that you can shoehorn in when your application gets breached. That's the problem with what's happening today. Companies, when they're designing their project budgets and their project plans, they don't think about this stuff. They don't think until it's too late and then Anonymous or whoever it is goes and tears them up a new one, and then they suddenly run around like scared chickens. We must protect our app, we must protect the user's data. Do it from the beginning. Yes, it means that your development phase takes longer. Yes, it costs you a little bit more. Yes, you might even have to get extra developers in who specialise in doing secure applications. But which is the cheaper of the two options? Doing that at the start, or having to mop up and pay out the lawsuit for 20,000 users who just had their data leaked all over the internet? Don't wait till it's too late. Employ a professional penetration testing firm to test your security. Bring in a good team who will look at your data, who will look at your system, give them access to everything they need. Let them come in and talk to the developers. Let them look at the source code. They're not going to steal your ideas. They're there to help you. You're paying them to help you. So let them look at the source code. And then let them go and do the job. If you get a good pen testing firm, not only will they attempt to hack your application and look for holes in the application, but they'll also attempt to socially engineer your staff. They'll make phone calls pretending they're from the ISP, something like that. So it's not just a test of your application or your code or how good you've written it, it's a test of your staff as well. And the people who you trust day to day to run your enterprise, to run your app, to run your website. That's it. That's all I've got for you. Thanks for listening. Thanks, Graham. Anyone?
You mentioned that the risk here is that you might get sued by 20,000 people. Has that already happened?
Actually, yes. I did a small stint out in the Middle East for the Royal Bank of Qatar. One of the reasons I was asked to go out there and work on that project was because 3 months prior to that, they had a massive breach in which I think it was something like 15,000 customers' credit card details were breached from the servers and released onto the internet globally. It turns out, however, that the servers themselves weren't breached. There was actually a bigger danger, and that was that the CVV number on the back of the card had been burned onto the chip and pin on all the cards in a plain text format. Now, these cards were also some of the first contactless ones available before it was introduced over here in the UK. And it was found that the cards were getting skimmed as people were walking past with scanners in the clothing, brushing more of people's pockets and siphoning the data out of the card and getting close enough to the card to get this unencrypted pin block out of the card and get the CVV and the pin numbers off the card. And what they'd actually done, they'd made this process so efficient in gathering these credit card details. They'd got so many numbers that the bank actually thought the servers had been breached when they hadn't. It was a pure data mining exercise. But as a result, yes, there was a massive lawsuit against the bank, and the bank actually nearly folded because of it.
There were some incredibly big hacks with millions of users. I'm thinking things like Adobe, Steam, eBay. You know, they're really big systems like that. And it seems almost inevitable that it's only a matter of time before we see the next one. So, as people who use these services, is there any way we can mitigate against this? Or some of those resulted in lawsuits, didn't they?
That's a very good and quite a tricky question as well. Well, yeah, I mean, I'm sure Doug's going to agree with me on this one. The best way of protecting yourself is don't use them.
Well, I suppose one thing is, would you like to store your credit card details on this server? No, thank you. I want to enter my credit card details every time, thank you very much. I don't want it, because I have no idea about security go back in.
Absolutely. I mean, some of the details don't need to be persistent. If you're not bothered about typing something in every time you want to use a service, then make a point. give your feedback to the companies in question. Say, look, I'm not happy with the way you do this. I want you to change your practices. Now, if enough people do that, and enough people walk away from the service, the companies are going to sit up and start paying attention. Because it is all about customer retention for a lot. And if they're not retaining the customers, that's what tells them absolutely, unequivocally, that they're doing something wrong. So make your points known. If you're a developer and you're working inside one of these organisations, go to your boss. Say, look, I don't like this, what we've written. I don't like the way we've engineered this product. Make your points known. Yeah? If your project manager is being a pain in the ass about it, and God only knows I've come up against a fair few of them over the years, then go above his head. It might seem like a shitty thing to do, but if you are genuinely concerned that the company you're working for is not doing the best they can to protect your public, and for that matter the staff and your colleagues that work in that company, then it needs to change. It's as simple as that.
You said about Twitter DMs not being secure. Does it matter now that Twitter requires HTTPS?
Sorry, say that again?
You said Twitter DMs aren't secure. And does it matter now that Twitter now has HTTPS requirement everywhere? Because the API can't do the normal HTTP anymore.
Yes and no. HTTPS is HTTPS. So HTTPS is, by its very nature, secure because it is an encrypted protocol. But if you're sitting in as a man in the middle, like I explained on a public Wi-Fi or something like that, there are now plenty of applications that can decrypt those in real time. I work a lot on the Microsoft Windows platform because I'm a Microsoft community leader and a lot of my clients run on the Microsoft stack. One of the tools that's available to us is written by a company called Telerik, and it's called Fiddler. Fiddler runs just like any other normal user space application on your Windows desktop. But if you're running it in the same environment where the public key certificates are available for the traffic that you're trying to watch, you can intercept those public key certificates and you can use them to decipher the traffic in real time as it's going across the wire. So there's plenty of applications out there that can do that. Firesheep, I'm not too sure. I know that there was some surroundings of that allowed it to unencrypt HTTPS. As long as you've not got man in the middle, and as long as there's nobody able to wiretap the connection, then yeah. If it's going across HTTPS and everything's going across HTTPS, it is secure.
Can I make 2 points on that? Because I see this all the time. Firstly, people use Twitter via SMS quite a lot, more than you think. So you at Orange had access to everyone's SMS records,
yep,
including those DM conversations. Secondly, how many people DM fail? Like the number of people who quickly delete stuff that I've screenshotted, whatever screenshot, but it's funny because they meant to send something via DM that actually has gone to their public stream.
Yeah,
so it's a really bad way of putting secure information out there.
You're at the mercy of fat fingers, internet conditions, and of course the obligatory drunken person in the pub on Friday night. You know? It can be made secure. Everything can be made secure. Is it inherently secure? Maybe, maybe not. But are you willing to take that risk? If you can do something about it and know that it's secure, then in my mind at least, that's the path you should be taking, not the one where there's a little bit of may.
Lithium do something better, which the Lithium social law, it requires you to go on a link, sign in with Twitter, and then do the number that's all over HTTPS. That's what I do.
So you mean like one of these aggregation services?
No, Lithium, it's a product that companies can buy and it does all the help desk stuff for them. And they use it on top of
right, yes, I know which one you mean. You get like the feedback button on the side, you click on it and it
I've
pops
got a
up.
thing for Twitter where you sign with Twitter and then you give the account number through Lithia itself, so you don't use Twitter itself.
Right. I'm not familiar with that.
Uh,
I know, I don't know if it's the same company. I know the one where you get the little feedback button on the side, you click on it.
there's lots of
Is it?
Yeah.
I'm not familiar with their use of Twitter, so I can't sort of give you an answer on that one, I'm afraid.
Okay, great, thanks.
One more. One
Yeah,
more.
what were you saying about test data and needing to secure that? Because certainly the way I develop things, the test data would never leave my computer. I would do all the testing on my computer.
Well, that's actually a very valid point. A lot of companies should ideally have two setups. You should have your development lab, and well, actually, you should have three setups, if I'm to be bluntly honest. Your development lab, your staging lab, your production lab. And each one of those, particularly where data is concerned, should have three independent database stacks. Unfortunately, in this day and age, and I'm sure James will back me up on this one, there's a lot of startups out there who are running on a very, very low budget, and they can't afford to do anything like this. So what they tend to do is they go and hire an Amazon server, they bang one database on there, and everything goes into that one database server. It might go into three independent database clusters on the server, but it's still pretty much in that one instance. I've even seen a lot of them actually just dump it all into one table just to save on costs. You know? So, yeah, it's like everything. There's a perfect way of doing it, and there's the real world way that it gets done. If you're putting everything into a separate database and you're testing your own stuff in a sealed entity away from the production entity, that's fantastic. Keep on doing that, because honestly, that's the type of mindset that developers need to adopt. 9 times out of 10, the developers don't have a say or a choice in what they're doing with regards to that kind of thing. Because the business comes down, the project leaders come down and say, right, this is our budget and that's how you're going to do it. And that's why we end up with problems surrounding that kind of thing.